Now, let me introduce to you the speaker for today. Our guest speaker for today's episode is Sir Romeo E. Bihar with his topic, Special Theory of Relativity. Sir Bihar, you can now take the virtual floor.
Magandang umaga po sa ating lahat. Maayong buntag sa atong tanan. Mayad nga aga sa atong tanan. And good morning, everyone. Okay, so welcome to the sixth episode of Science Eskwela. And this is Sir Reb Romeo Jr. Ibihar, your lecturer for today's episode. Hopefully nakakain na po tayong lahat. Hopefully nasa mabuti at maayos po tayong kalagayan. And hopefully nasa maayos at komportable po tayong kinauupuan. By the way, thank you very much to the Cosmos Club of General Santos City National High School, Senior High School, for inviting me as your lecturer for today's lecture. To the club president, Ms. Wendy Nidogma, and to the rest of the officers and the technical team, maraming salamat po, and most especially to the club advisor, Ma'am Dailene Grace Velasco. Thank you very much. So for this episode, we will be talking about the special theory of relativity. Ayan, so without further ado, buckle up and let's travel through time and space. Ladies and gentlemen, here are our learning competencies. At the end of this session, hopefully we can describe how Hertz produced radio pulses and explain how special relativity resolved the conflict between Newtonian mechanics and Maxwell electromagnetic theory, and explain the consequences of the postulates of special relativity. And these are the relativity of simultaneity, the time dilation, the length contraction, the mass energy equivalence, and the cosmic speed limit. Ayan. So disclaimer lamang po ha, I am not a physicist. I am not a physical science major. I am not a science teacher by profession, but I guess I have this little knowledge about this topic worth sharing. So if I will be making mistakes or might be sharing wrong information later, I will be much willing to be corrected. After all, this is not an avenue to monopolize learning. And having said that, our comment section is always open for your comments, additional information, and suggestions. Ayan. Mag-vlog tayo ngayon. Okay, para maiba din yung ating science eskwela, di ba? Okay po. So this morning, I will start my discussion with the Hertz production of radio pulses. And this is our learning competency number 1 on how Hertz produce radio pulses. Ayan, so okay lang ba tayong lahat? So let me first review the different types of electronic radiation. Ayan po. So starting off from the right side of our image, there we have the gamma ray. So gamma ray is used in medicine for killing cancer cells. Then we have the X-ray that is used to view inside of bodies and objects. We also have the ultraviolet ray, which is absorbed by the skin and is used in fluorescent tubes. And the visible light, the famous Roy Jabiv, diba? The red, orange, yellow, blue, indigo, and violet. And these Roy Jabiv lights, or the visible lights, make things able to be seen. Next, we have the infrared that transmits heat from sun, fires, and radiators. We have microwaves that are used in cooking, radar, and telephone and other signals. And one of the 7 waves also in the electromagnetic spectrum is the radio wave. Ayan. So based po sa image natin na andyan po sa screen ninyo, it has the longest wavelength and the highest and has the lowest frequency among all the waves in the spectrum. So radio wave is widely used to broadcast radio and television. At alam niyo ba na ang radio wave was first discovered by a German physicist na may pangalan na Heinrich. Heinrich. Kasi sabi daw ng pronounced pronounceyournames.com that is pronounced as Heinrich daw. Heinrich because it's German. So Heinrich. Ayan, so Heinrich Rudolf Hertz. So ulitin ko po. Yung radio wave daw was first discovered by a German physicist na may pangalan na Heinrich Rudolf Hertz while attempting to prove the electromagnetic wave theory of James Clerk Maxwell. And he also and Hertz was also able to create the first man-made radio wave. Hindi lang po siya nakadiscover na meron talagang radio wave existing, but also he was able to create the first man-made radio wave. Ano bang ginamit niya dati for him to discover the first or to create the first man-made radio wave? Ito po yung device na ginamit niya. Ayan. So, yan po yung pagka-connect-connect ng mga devices niya. So, meron po siyang ginamit na induction coil. Next, meron din siyang ginamit na Leyden jars that serve as the condenser. Alam na alam niyo yan yung condenser ngayon, di ba? So, nowadays, yung condenser is being represented by in electronics, yung ating mga capacitors dyan. And as spark gap. Yung spark gap, connected siya sa induction coil, tapos another connection naman doon sa ating antenna. And given this configuration, he was able to produce and or create the first man-made radio wave and meron pong mga sparks na andyan in between sa ating spark gap. Ayan. So dati, during his time, merong mga marites din. Sabi ng mga marites dati, ay, atik man na siya, that is a lie. Why? Because walang proof na meron talagang emission of the radio wave or emission of the radiation. Ay, hindi yan makakaproduce ng, o hindi yan siya makakreate ng radio wave. So, anong sabi ni Hertz that time? So to prove that there really was a radiation emitted, so dapat merong detection ng ating radio waves. So ang ginawa ni Hertz at that time, ito po yun. On the left side of the presentation, andyan yung artist illustration of what happened that time. Nasa right side po ng ating presentation, andyan po nasa baba yung schematic diagram ng device na mismong ginawa ni Hertz for him to produce the radio pulses or the radio waves. Nang nasa taas ng schematic diagram, yan po yung instrument na ginamit niya for him to detect the emission of the radiation. So ano yung nasa taas na yan? He used a piece of copper wire, then he bent that wire into a circle na may seventh sphere on one end, and the other end of the wire was pointed with the point near the speed close to that of the transmitter. At ano ang nangyari? Ayan po yung ating instrument ha para ma-detect po yung emission ng radiation. So ano po yung nangyari diyan? Nagkaroon po ng, of course, kanina as what I've said, nagkaroon ng spark between the spark gap at saka nagkaroon din ng spark across the tiny gap between the point and the sphere. At dahil dyan, shut up ang mga marites. And there he discovered the first ever, or he created, the first ever man-made radio wave. At dahil dyan, palakpakan natin si Heinrich Rudolf Hertz. Yay! Ayan po, hindi lang po iyan ang contributions ni Hertz sa science. Ano pa yung mga ibang significant contributions ni Hertz sa science? Ito po. Hertz was not only able to detect the waves, but he was able also to measure the wavelength and the velocity of the waves. He also calculated the speed of waves, which is equal to the speed of light. Later, I will give you the speed of light, as Maxwell had predicted. At alam niyo ba yung frequency na tinatawag natin? Yung frequency, yan po yung number of cycles created in a unit of time. At alam nyo ba kung ano yung unit to measure the frequency? Ang unit po ay ipinangalan mismo kay Heinrich Rudolf Hertz. At ang unit po to measure the frequency ay ang Hertz in honor of his name. Ayun po. So aside from this, with these contributions and aside and other more contributions of Hertz in science, he opened the door to the invention of the wireless telegraph, the television, the radio, and other forms of telecommunication technology, as well as diagnostic technology that today help ease people's life and work. O, di ba? So again, palakpakan ulit natin sa Hertz kasi kung wala si Hertz, wala po tayong TV. Kung wala si Hertz, wala po tayong mga comments or additional information po regarding our discussion for this section. You may use po, allow me to say this one, you may use po the comment section para at least, sabi ko nga, it is not an avenue for me to monopolize learning. So baka meron pa po kayong ibang alam regarding this one. So the comment section for these po na video so is always open po to cater your additional info and comments. Later, if we have still time, we can read po your comments. So, nagba-vlog lang. You can read po your comments po regarding our discussion. Ayan. So, for a while lang po muna ha. Let me just unmute my phone. Okay, so that's it. Now, we will then be discussing this time the second learning competency, which is to explain how special relativity resolved the conflict between Newtonian mechanics and the Maxwell's electromagnetic theory. So we will be discussing the Newtonian mechanics versus the Maxwell's electromagnetic theory of light versus Einstein and the special theory of relativity. Dati pa, meron na po tayong mga great theories of physics. Yes po. Isa or dalawa sa mga great theories of physics ay ang mga ito. Una, the three laws of motion by Isaac Newton and the theory of electromagnetics by Sir James Clerk Maxwell. So kung mapapansin po natin dyan sa image, snabero po si Newton. Ayan, kahit nagpipid na po si James Clerk Maxwell, nagsasorry na siya kay Isaac Newton, snub pa rin po si Isaac Newton. So, para po ma-please natin si Isaac Newton, i-review po muna natin kung ano ang contributions niya sa field of physics. Ayan po. So let's review the three laws of motion formulated mismo by Sir Isaac Newton. Sige, unahin po natin yung first law of motion or yung sinasabi nating the law of inertia. Anong sabi dito sa first law of motion or law of inertia? Sabi daw, an object or mass will remain either at rest or in motion in the same direction unless acted upon by a non-zero external force. Yun po. The second law of motion, which is also known as the law of acceleration, states that the acceleration of an object is directly proportional to the magnitude of the net force and inversely proportional to the mass of the object. Given the second law of motion, it gave birth to one of the famous formulae in the field of physics. At ano iyon? That is F is equal to M times A. So M there or F there stands for the force, the M there is for the mass, and the A there is for the acceleration. Now, with regards to their units, for the M or the mass, that is kilogram, for the acceleration, that is meter per second squared. So therefore, we can say that the unit to measure the force is kilogram times meter per second squared. But force has its special name for the unit. At ano yon? It is named again after the famous Sir Isaac Newton, and that is Newton. So again, the unit for us to measure the force that is Newton. Okay? So proceed po tayo sa third law of motion, also known as the law of interaction. Anong sabi ng third law of motion? In every action, there is always an opposite and equal reaction. Ayun po. So given all of these statements coming from these laws of motion by Sir Isaac Newton, we can say that the space or the distance, the time, and the mass are absolute. Anong ibig sabihin yan? Yung distance daw, sabi ni Newton, between two objects and the time that passes between two events does not or do not depend on the environment where the object is in. Karagdagang info, furthermore, sabi ng second law of motion ni Newton na ang objects in the environment moves in a straight line. Therefore, the change of location from one environment to another environment must register a straight line to other straight lines, which is very self-explanatory naman if you will perform this one, 'di ba? Moreover, sabi niya pa, it is said that no matter where you are, kahit saan kang parte ng mundo, Pilipinas ba or saan lupalop ng mundo, and or how fast you are moving kahit gaano ka kabilis gumalaw, sabi ni Newton, there will be no changes in space or time. Anong ibig sabihin yan? So in all places, Pilipinas man or abroad or kahit nasa ibang bansa, the kilometer is always kilometer. Hindi yan magbabago. And the minute is always a minute. Hindi yan magbabago. You can travel as fast as you can or as fast as you want with adequate acceleration. Yun po yung sabi ni Newton na nakabase sa kanyang three laws of motion. So tapos na po tayo dito kay three laws of motion. Let's review also yung sa electromagnetic theory of light ni James Clerk Maxwell. Kasi baka magsiselos siya. Ayan. So una, ang sabi niya, he predicted that the electric field, the magnetic field, and the light are different representations of the same phenomena or event. In addition to that, sabi niya rin, or he predicted, na ang visible lights daw are electromagnetic waves. Na ang visible lights move in a manner like a ripples in the water when a stone is dropped. Kagaya po ng nasa image na nasa screen po ninyo. So ganyan daw ang representation ng visible lights. And he also said na yung visible light daw, it moves at a constant speed of 186 miles per second. Or if we will convert miles per second into kilometers per second, that is roughly 300,000 kilometers per second. Ay ganun kabilis mag-travel ang light. Imagine, sa isang second, it can travel at 300,000 kilometers. Eh, what if i-convert natin yan into meters per second? So that is roughly 300 million meters per second. So ibig sabihin nun, sa isang segundo, eh makaka-travel ang light ng 300 million meters. Kita mo, ang napakabilis mag-travel yung light po natin. So yun po yung kanyang mga statements regarding the electromagnetic theory of light. So ang question ngayon, ano nga ba yung conflict ng dalawang theories na to? Ano ba yung problema nila? Bakit merong conflict na tinatawag? Ang conflict lang ani actually kay daghan puro sila bright. Oh, moro jud na actually ang conflict. Puro duha sila, puro bright, wala joy magpapildi. Oh, imagine, kung naamo sa isa classroom, then puro ang mga classmates ninyo, puro bright. O, di ba? Lantaw-taw, walay magtalupig. Puro debate. Di ba? So, another example, kung naamo sa ma-employ mo sa isa ka workplace na puro bright, 'di ba? So unsa matabo, wala po'y magpalupig. Oo, pataasay o garbo ug ihi, puro debate na lang. So actually mao gina ang conflict. Joke lang po. Kidding aside, yung conflict nila actually isa lang. There is only one conflict between the two theories. Ano po iyon? Yung side kasi ni James Clerk Maxwell in his theory of electromagnetics or theory of, ano yung sabi ko kanina? Theory of light or the electromagnetic theory of light, ang sabi niya lang, ang light daw, if it travels or it moves in a vacuum, it moves at 186,000 miles per second. And it does not change for all observers and situation. Ayan po. So yung light daw, if it is in a vacuum or in a deep space, nagta-travel po siya ng 186,000 miles per second at hindi po siya nag-change para sa lahat ng observers and for all situations. Pero sabi ng three laws of motion naman ni Sir Isaac Newton, hindi. All speeds are relative. Ang ibig sabihin nun, ang speed nakadepende on the observer's viewpoint and situation. Pero di ba sabi ni James Clerk Maxwell, hindi, it does not change para sa lahat-lahat ng mga observers at lahat-lahat ng situation. Eh sabi naman ni Sir Isaac Newton, gamit yung three laws of motion niya, ay hindi, nag-change yon. Nakadepende kasi yan siya sa observer's viewpoint and situation. So, conflicting talaga ang ideas ng dalawang ito. So, paano po masolve yan? So, here comes in 1905, nagpasok sa eksena si Sir Albert Einstein na walang hairstylist. Ayan po, si Sir Albert Einstein. Ayan. So, ano po yung sabi ni Sir Albert Einstein dito? Sabi niya, yung Newtonian physics ni Sir Isaac Newton, tama yun. Walang problema. Yung Maxwell's theory, yung electromagnetic theory of light ni James Clerk Maxwell, totoo yun. Tama yun. Wala rin problema. Pero, let me just lay down these principles of mine that are based on the observations of events from different viewpoints. Sabi niya, hayaan niyo ako paghintulutan niyo po ako na i-present yung mga principles na to. Baka makakatulong ito in the near future. Ano-ano yung mga principles ni Sir Albert Einstein na somehow nakatulong to resolve the conflict between the Newtonian mechanics and the electromagnetic theory of light ni James Clerk Maxwell. Ito yung dalawa. Una, the consistent law principle at ang pangalawa is the constancy of speed. Ano yung sabi ni consistent law principle? Ang sabi niya daw, all motions are relative to the selected reference frame or viewpoint. Other references may say, the laws of physics are the same in all frames of reference that are moving at a constant velocity with respect to one another. I'll give you some of these examples for us to better understand what consistent law principle is. Say for instance, meron tayong train or tren. Wala naman tayo dito sa Mindanao. O sige, pagpa na lang natin. Let's just be hypothetical. Pagpalagay natin lang natin na meron tayong tren dito sa may General Santos City. May isang boy na nasa loob ng tren at yung tren passes between dalawang trees. May isang boy na naman na nasa labas ng tren on the train platform na nakatingin or naka-stare or naka-watch as the train moves from left to right. Ayan po. So, at that instant, let's have the perspective ng nasa loob ng ating tren or train ha. So, few minutes later, nagkaroon ng lightning strike. So, nag-strike po yung lightning sa both trees niya. Sa both niya ha. But I mean sa both trees, sa left at saka right. Sa viewpoint or perspective ng nasa loob ng tren, mas nauna niyang napansin or nakita yung tree na na-strikean ng lightning sa left kesa sa right. Pero yung observer na nasa labas ng tren, parehong nakita niya at the same time na nag-strike yung lightning sa both trees. Yan po yung special theory of relativity. Okay? So para mas maintindihan po natin ulit, again, nakadepende po yung sabi po dito sa consistent law principle, nakadepende po yung ating motions or yung ating speed, or should I say motion, doon sa ating selected reference frame or viewpoint. Kasi yung perspective po ng nasa loob ng tren, iba din po sa perspective or viewpoint ng nasa labas ng tren. Sige, let's make it more contextualized. Let's say we are in a bus na nasa Bulaong Terminal. Say for instance, yellow bus line. Tapos, katabi nun, adjacent lamang po, merong another bus. Puno na, ready to go na yung isang bus na yon. Tapos ikaw, nag-iisa pa lang. Nag-iisa pa lang. Alone, doon sa may bus na sinakyan mo. And here comes, paatras na yung bus na adjacent lang ng bus na sinasakyan mo. Have you noticed or have you ever asked yourself, hala, nagalakaw na ba ang bus na ako ang gisakyan? Kinsa ang bus nang nagalakaw? Have you ever asked yourself about that? Kasi if ever you have asked yourself about that, you are a keen observer and you actually experience the so-called special theory of relativity. Ayan. Another example naman is this one. Sige, nakalarga na ang bus na to para for fairness and justice. Nakalarga na. Along the highway na yung bus. Nagalarga ang bus at a constant velocity. Here comes. Nasa outer lane, may another bus na nakapass by sa atin. Have you ever noticed and have you ever asked yourself na, hala, nagpunto ba ako ang bus na ginasakyan? Ana? Hala, nag-stop ba ang bus? Hala, kung saan nagadagan ang bus na ako or sa kabila na bus? Have you ever asked yourself about that? Moves in a speed of 186,000 miles per second and is the same for all observers' viewpoint. Other references may say the constancy of speed states that the speed of light in an empty space or in a vacuum has the magnitude for all observers regardless of their velocity. Yun po yung yun po yung para sa kay Albert Einstein with respect to his constancy of speed principle. I'll give you an example for you to better understand this principle. So po tayo sa lupa, punta tayo doon sa outer space. Nakasakay ka sa isang outer space, nakasakay ka sa isang spaceship, na towards or approaching the source of light. Then, yung isa naman, you pass by or may nag-pass by sa iyo na other na pod na hypothetical lang po ito ha. Other po na spaceship pero it moves away from the source of light. So, ano po ba yung ating speed of light when it comes to that situation? Ang speed of light po natin dyan, or speed of light is the same sa perspective ng astronaut na nakasakay sa spaceship approaching the source of light and sa astronaut na nakasakay sa spaceship na moving away from the source of light. So in short, regardless of the rate of movement or the source of light and the rate of movement of the astronauts, the speed of light will remain the same. So, yung dalawang postulates na ito, kina-clarify niya lang na kung merong dalawang events na nangyari at different places, it is not always likely to say which of the two events happens. Kasi parang puro attendance na lang po nakikita ko sa comment section. Kung meron po kayong additional info, maybe you can share so that I can also share that one through this live po na session sa mga ibang nanonood at nakatune in po sa session natin ngayong umaga. So that's it. Now, let's have the third, the third learning competency for this na discussion, for this na session. And for this, we will be explaining the consequences of the postulates or the postulates of special relativity. So let's have first the review of the two principles laid down by Albert Einstein as he resolved the conflict between the Newtonian physics and the James Maxwell's electromagnetic theory of light. So review lamang po tayo ha. Una, yung sabi ko kanina, the consistent law principle na it is assumed that the laws of physics are the same in all inertial reference. By the way, what makes a special theory of relativity special? Oh, kasi meron tayong tinatawag na general theory of relativity. Eh bakit meron tayong tinatawag na special pa na theory of relativity? What's so special about the special relativity theory? It is because each observer's reference frame or the viewpoint or the perspective of the observer is a special type of reference frame. Ayun po. At ang tawag po doon is the inertial reference frame. Ang ibig sabihin lamang po iyon na yung observer is at rest and not accelerating from the observer's perspective. Kasi nga po, there is no such thing as at rest. Or should I say, mali po, there is no such thing as absolute rest. Basta absolute gani, maragwa gina siya. Kasi nga po, everything po is relative. Ayan. So sa perspective ko, kung andito po ako sa may, say for instance, kung nasa fourth floor po ako, tapos I am looking at doon sa student na nagarampa along doon po sa ground. So, iba po yung aking perspective at iba rin po yung perspective ng tao na nasa ground. Kasi nga po, everything po is relative. Nakadepende po siya doon sa viewpoint ng ating nakadepende sa viewpoint ng observer. Yan po yung ating first postulate, yung consistent law principle. Another one is the constancy of speed, and it is assumed na the speed of light in a vacuum is always the same. No question for that. The consistent law principle is also known as the relativity postulate, and the constancy of speed is also known as the speed of light postulate. Ayan, so let us explain the different consequences of the postulates of the special relativity theory. So what are the consequences of the postulates of the special relativity theory? We have the relativity of simultaneity. If two events are separated in space or position, it is absolutely impossible for the two events siya ng trend po natin and he is watching as the trend or the train moves, the train moves from left to right. Ayan po. So, unahin po muna natin dito sa observer A po natin. So, as the observer A switches on the light, so the time the light takes or the time it takes for the light from the bulb to reach both the front and the back door is the same, since the speed of light is constant. So assuming that the train is moving at constant velocity. So yan po. So kung andyan po ako sa loob ng train na yan, so as I switch on the light, so ano po mangyayari? So sa palagay ko, yung time po it takes for the light from the bulb to reach both the front door and the back door is the same. Because for me, or because, yes, obviously, the speed of light is constant. However, yung nasa observer B po if we are the observer B, yung nasa labas ng trend. So, as the observer B, outside the train, watches the train moves from left to right. So, ang kanyang viewpoint naman, yung nasa perspective niya, yung back door of the train is moving towards the light source. Whereas, the front door of the train is moving away from the light source. Kasi nga, the train is moving from left to right. So ano po yung kanyang conclusion? Masasabi niya na the time that the time it will take for the light to reach the back door will be shorter than the time it will take to reach the front door. Yun po. And that is the relativity of simultaneity. Sa palagay niya, yung time daw for the light to reach the back door is shorter kesa doon sa time na yung light will reach the front door. Kasi nga po, sa palagay niya, since the train is moving from left to right, yung back door is moving towards the light source. And the front door is moving away from the dark source, from the light source. Ayun po. So for both observers, merong isang event lang na nangyayari. For observer A, yung time of the light reaching both the back and the front doors are simultaneous. However, para naman kay observer B, they are not. So, that is the principle of the relativity of simultaneity. Again, an event is only simultaneous for an observer, but not necessarily simultaneous for another observer. Ayan, so hopefully klaro na po itong ating relativity of simultaneity. Next naman na consequence is yung time dilation. Ito yung resulta ng ng mga postulates ng special theory of relativity. Ano po itong time dilation na tinatawag? It is the apparent or the obvious difference in the time. So if you say apparent, obvious talaga. In the time interval between two events as measured in clocks. Einstein concluded that the faster you move through space, the slower one moves through time. It is then mathematically described as, ito yung mga paborito ninyo, basta may mga formula at saka meron ng mga problem solving, paborito nyo yan. Diba? Ayan. So, clap lang muna para hindi halata. So, meron po itong mathematical description. And it is described as this one. The delta t or the change in t is equal to the change in or delta t sub 0 divided by the square root of 1 minus v squared divided by c squared. Where the change in t there, that is our time or the dilated time interval from the perspective 300,000 kilometers per second, or in meters per second, that is 300 million meters per second, or in miles per second, that is 186,000 miles per second. Ayan po. So, for us to apply these po na formula, let's have these following example. The astronaut's ship is moving constantly at 80% speed of light, or 0.8 c. How long is 1 year on the spaceship compared to 1 year on Earth? So we have the formula. The change in t is equal to the change in t sub 0 divided by the square root of 1 minus v squared divided by c squared. Substitution, the change in t is equal to our change in t sub 0, that's 1 year, divided by 1 minus our v, that is 0.8 c squared divided by c squared. Distribution, 1 divided by 0 square root of 1 minus 0.8 squared c squared divided by c squared. C squared divided by c squared, that is 1. So that yields us to 1 divided by square root of 1 minus 0.8 squared. Using your calculator, this equation will yield us to 1.67 years. That only show na ang 1 year here on Earth will be an equivalent of 1.67 years on that spaceship. Akalain mo, mas advanced sila. That's the consequence of the postulates of the special theory of relativity, the time dilation. So roughly, yung 1.67 years, that is 1 year and 8 months. Akalain mo, bago pa lang tayo nag-New Year dito, sila doon, malapit na mag-New Year for the second time. O, diba? So, ayan. So, that is time dilation. If meron time dilation, meron din tinatawag nating length contraction. And this is the third consequence of the postulates of the special theory of relativity. Ano po ito? It is the phenomenon in which an observer at rest would observe a moving object's length to be shorter than its proper length. Ayan. So hindi lang po yung time. Hindi lang po yung time yung nag na nag 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 humahaba. But then, ang length or the equals L sub 0 square root of 1 minus V squared divided by C squared. So L there, that is the contracted length from the perspective of the observer on Earth. The L sub 0, that is the proper length from the perspective of the observer on the ship. Yung V there, that is of the ship, as long as the ship is moving at constant speed. The C there is the speed of light, or 0.8 c. What is the contracted length or the distance from the Earth to planet as observed by the ship? So contracted length po ang hinahanap natin. So here we have the formula L is equal to L sub 0, square root of 1 minus V squared divided by C squared. Meron po tayong next substitution. L is equal to L sub 0, that is 10 light years. Square root of 1 minus 0.80 c squared divided by c squared. Our V there, it's 0.80 c. Distribution, 10 square root of 1 minus 0.80 squared c squared divided by c squared. C squared divided by c squared, that is so that yields us to 10 square root of 1 minus 0.80 squared. Using your calculator, this will yield us to 6 light years. That only show na for the observer here on Earth, the distance between Earth and the planet is 10 years. Pero sa observer naman on the ship, the distance between the Earth and the planet is 6 light years. So 6 light years. Alam niyo ba ang 6 light years? I-convert natin siya sa may ilang kilometers pa siya. Alam niyo ba ang 6 light years into kilometers? Ang 6 light years po, that is 5.68 times 10 raised to positive 13 kilometers. Ganun po siya kalayo. Okay? So, that's it. So, masasabi natin na ang observer doon sa ship on a deep space at a constant speed, mas shorter yung kanyang observation, yung kanyang perspective, yung kanyang viewpoint regarding po sa distance ng ating heavenly body from one heavenly body. Okay, so tapos na po tayo sa pangatlo. Proceed po tayo sa pang-apat na consequence of the postulates of the special theory of relativity. At ang sabi dito, the mass-energy equivalence. Ano ang sabi ng mass-energy equivalence principle? That anything that has a mass also has an equal amount of energy. And that is very true, actually. This is one of the famous statements of Sir Albert Einstein. Albert Einstein. And because of this, he formulated one of the famous formulae in the world of physics, and that is E is equal to mc squared, where E there's the energy, m it's the mass, and c is the speed of light. So that's it. Next, the last but not the least consequence of the postulates of the special theory of relativity, and that is the cosmic speed limit. Kasi sabi nila, dati pa noon pa, sabi nila, ay, walang limit ang speed. Oo, wala siyang limit. Kahit ano pang kalaki yung speed na yan, walang limit. But then, as consequence of the postulates of the special theory of relativity, tinuldukan iyon ni Einstein. At ang sabi niya, there is a speed limit. Yes. Ano yung speed limit? Yung speed of light in a vacuum. Ibig pong pala sabihin nun, wala na pong makakapantay sa speed of light. And that is 180,000 miles per second, or in meter per second, that is 300 million meters per second, or in kilometers per second, that is 300,000 kilometers per second. Ladies and gentlemen, those are our consequences of the postulates of the special theory of relativity. And we have already attained the competency for this discussion. So again, our learning competencies and hopefully may naintindihan um, the relativity postulate. And the constancy of speed is also known as the speed of light postulate. And pangatlo, we have already explained the consequences of the postulates of special relativity. Tandaan lang po natin na meron tayong 5 according to Albert Einstein. The relativity of simultaneity, walang simultaneous po na event sa dalawang tao or sa tatlong tao or sa apat na tao and so on and so forth. Might be iba po happening or iba pang observation sa viewpoint po ng isa compared po doon sa viewpoint ng isa, especially yung isa is at rest at yung isa naman is moving at a constant speed. Then the time dilation, gamit po yung ating mga postulates of special relativity, masasabi po natin na yung time is shortened po siya dito sa at rest here on Earth compared po doon sa deep space na nakasakay sa mga spaceships na moving at a constant speed. Length contraction, ang sabi po doon na meron po tayong nagsushorten po, nagko-contract yung ating distance from one heavenly body to another. The heavenly body depende po sa viewpoint ng nasa tao or observer at rest here on earth. At speed limit, meron pala tayong limit when it comes to speed. And that is the speed of light. For any speed of light in a vacuum. Sabi po ngayong umaga. And having said that, uulitin po, maraming salamat. Thank you very much sa lahat po ng mga naka-tune in from the very beginning up until this time, up until the end of this episode. Maraming salamat po at maraming salamat din po sa walang sawang suporta sa Science Eskwela ng Cosmos Club ng General Santos City National High School, Senior High School. Sa muli, this is Sir Reb Romeo Jr. Ibihar, your lecturer for today's episode. Mayad nga aga sa atong tanan, amping perme to God be the highest glory. City high. Ahu.